Hello, everyone. Thank you for joining. This is our second day of Career Week, MESA's Career Week. We are joined by Intel today, and I'm going to give a short introduction before we pass it off to our panelists. Okay. So just as a reminder, this session is being recorded. So if you're coming in late or leaving early, you can go ahead and watch the rest of the session on our YouTube channel. We'll be posting all of our sessions next week onto YouTube. Audience video and audio features are off. Please use the Q&A button to submit questions. You can upvote your favorite questions, and you can do that as we go along. You don't have to wait until the Q&A starts. Use the chat for conversation. Do not share personal information such as your email and phone number in the chat, especially if there are any minors joining. And we will remove people who will post inappropriate content in the chat or Q&A. I'd like to state our land acknowledgement. So Oregon Mesa is located at Portland State University, and the university is located in the heart of downtown Portland, Oregon, in Multnomah County. We honor the indigenous people whose traditional and ancestral homelands we stand on: the Multnomah, the Cathlamet, the Clackamas, Tumwater, Lala bands of the Chinook, the Tualatin Kalapaya, and many other indigenous nations of the Columbia River. It is important to acknowledge the ancestors of this place and to recognize that we are here because of the sacrifices forced upon them. In remembering these communities, we honor their legacy, their lives, and their descendants. Okay, so today we're joined by 4 engineers from Intel Corporation. Intel designs, manufactures, and sells computer components and related products. The company was founded in 1968 and has been in Oregon since 1974. As of January 2021, there were close to 21,000 employees in Oregon alone. So I'll give a brief introduction to our speakers, and then we will pass it over to them for their presentation. Right. So we are joined by Alex Berry, who's an industrial engineer and technical program manager, and Namitha Somasundaram, and a design verification engineer. Rebecca Whiteman, who is an ultra-pure water facilities engineer, and Shayan Dev Sinha, a defect metrology and yield engineer. And with that, I'll pass the screen over to our presenters.
Folks, we are so happy to be joining you all today. You've got 3 very, very different types of engineers on the line. We hope that we can share some career perspective. To give a little bit of a deeper intro, I'm going to pass it off to our wonderful water woman herself, Becca. Becca, tell us a little bit about who you are.
Yeah, hi everyone. My name is Becca Whiteman. Like Alex said, I'm a ultra pure water facilities engineer at Intel. A little bit about me: I'm originally from Austin, Texas. I got a bachelor's degree in chemical engineering at Texas A&M University. I also like cooking, skiing, and hiking. It's nice that I can ski up here in Oregon. There wasn't much skiing to do in Texas. And since it's International Women's Day, we're all going to share a woman that inspires us. A woman that necessarily inspires me is Temple Grandin. And if you don't know who she is, Temple Grandin has autism, and she had a certain affinity to animals and animal behavior. And she used her knowledge and her skills to really revolutionize the livestock and agriculture industry. There's a really cool movie about her life. I think it's on Amazon Prime and HBO. If you want to watch it, I'd really recommend it. But that's a woman who inspires me. But back to water. What is ultra pure water? You might hear me call it UPW. In the semiconductor manufacturing process, UPW is it's used in a bunch of different processes, but the semiconductor manufacturing process has to be very pure, no particles, no contaminants at all. So UPW is essentially water that's removed of all contaminants. It's used in various different processes. I don't know all the processes that it's used in, but I do work on the systems that make the water. And kind of a fun fact about ultra pure water is that you cannot drink it. Water, when it is so pure in this state, it's actually very unstable. And so it needs like minerals and organics and salts and impurities in the water to make it stable. So ultra pure water is not very stable. if you were to drink it and only to drink ultra pure water, it would actually leach all the electrolytes from your body. So you're not supposed to drink it, but it's really helpful in the semiconductor manufacturing process. You can go to the next slide. So I thought I'd share a little bit about my career and how I got to the point that I'm at now. It did actually start when I was in high school. My high school summer job was a lifeguard. I did that for 5 years. And this is actually the pool that I used to work at. I spent a lot of time in the left-hand corner there. And I realized that I really liked working. My first priority was safety, of all the people that were at the pool, just like it is now at the plant. I need to make sure that all of my equipment is operating in a safe manner, that everyone that's working on my equipment is safe. But my second priority is operations, just like it was at the pool. I needed to make sure that the chlorine was at the right level, that the pH was balanced. And we had some interesting issues with the pool also, because the pool was in Texas. It actually got really, really hot. And by mid-July, it felt like bath water. So we were able to kind of make this spraying device where we would turn it on at night and it would cool the pool water down. And I did some pump repairs, and that was all in high school. And when I was trying to figure out what I wanted to major in college, I realized that I really liked doing that type of work. So I figured I would major in chemical engineering. So that's when I went to Texas A&M and studied chemical engineering. And a lot of what Texas A&M is focused towards is the oil industry, since a lot of jobs in Texas for engineering are for the oil industry. And I didn't really want to work in the oil industry. I wanted to do something a little different, but I wasn't sure what yet. So I started looking for jobs that were outside of Texas. And that's when I found the job that's pictured above my first internship. Was at a coal power plant in Missouri, and I was working on implementing EPA regulations for wastewater, so we could clean up the water, so it was clean enough to go back into the Mississippi River. And this was kind of my second experience working with water. I really enjoyed it. I got to learn about working at an industrial environment, working on a large-scale project, and these are all things that I really, really liked, and I wanted to continue doing, but maybe not necessarily in such a heavy industrial, dirty kind of environment as a coal power plant. So then I went back to school to continue studying, and I got my second internship, which was with the Ultra Pure Water group at Intel. So that is what I do now. That's the group I work in now. And I really, really enjoy it because it is still industrial. There is so many things going on every day, but it's very clean. I feel very safe going to work every day, and I really like it. But what do I do on a daily basis? Like I said, I'm a facilities engineer, but a lot of other people call me a system owner. So this is something that I own, all of this ultra pure water equipment. This is my system that I own. I'm in charge of all of the maintenance, all the operations that go on the system. Usually my day starts with reviewing trends. I will meet with technicians and we'll plan maintenance activities. Sometimes I get alarms that I have to go respond to in the field. And this is all, part of my daily day. And depending on the day, it could be really fast paced or it could be an easy day. That's part of what I like about it, is there's always something new. I'm always learning. It's a very complicated process that this water has to go through before it's ready for the factory. And so I can really continue to learn about this probably my whole career, and I still won't know everything about ultra pure water. And that's something that I really, really like. I really like that challenge. Yeah, that's about it for ultra pure water.
Wow, I love it. I'm not gonna lie, I just went and learned a whole lot about water and ultra pure water in general. So thank you for teaching me all of that. And now I know we've been joined by our wonderful friend Shayan Dev, but before we get to him, we want to go and pass it over to Namitha, who is a very, very different type of engineer than Becca. So Namitha, tell us a little bit about who you are.
Hi, everyone. So Alex, if you can just, for each point, you can go through the slides. I'm Namita Somasundaram. I'm a design verification engineer with Intel. My journey started in a southern city of India called Chennai. That's where I majored in electronics and communication engineering for my bachelor's. After that, I graduated from Virginia Tech with a master's in computer engineering. I've always wanted to work with Intel since the time I first owned my PC. So I was very glad when Intel was my first job. One of the proudest achievements that I have with Intel is contributing to Intel's first persistent memory product with the 3D crosspoint technology. That was a technology that Intel and Micron co-developed. I work on a team which does the memory controller for the product. To honor the International Women's Month, I've listed two women who inspire me the most. The first is Kalpana Chawla. She was an Indian-born American astronaut and engineer who was the first woman of Indian origin to go to space. She first flew on the Space Shuttle Columbia in 1997 as a mission specialist, but also the primary robotic arm operator. Her second and final flight was on the Space Shuttle Columbia in 2003. She inspired me to see how United States is a land of opportunity and with cutting edge technology. I came to the US for my master's, largely based on this inspiration. The second woman who inspires me the most is Ali Miller. She was the youngest female employee to ever create an artificial intelligence device at IBM. She led a large-scale product team through leading with computer vision, data, and regulation. She currently heads the US AI market growth for startups and venture capitalists at AWS, supporting multiple large organizations of AI within the US. Her career progression greatly inspires me to constantly keep learning and forging my own path forward. I love to keep learning. I'm currently reading the book called The Inevitable by Kevin Kelly, where the author forecasts the 12 different technological forces that will shape the next 30 years. In my spare time, I read books on business, investing, and self-help books. One of the things that I'm really passionate about is helping people overcome their fear of public speaking. And I do this through Toastmasters. This happened because during my 5th grade, I gave a speech in front of an audience and I panicked and I spoke like one of those TV commercials, like so fast that no one understood at the end of it what they had heard. That was me. With great difficulty and great effort, I changed that during my college days. Now I'm really passionate about helping others become better communicators. I enjoy trying new things. During the pandemic, very early on, I was fortunate enough to be able to do a cross-country road trip across the US, visiting various new places. A fun fact about me, I won the first place in the adult figure skating level 4 competition. I know that's not a big deal, but it was something that I've always wanted to do. And when I won the first place, I was really happy. Alex, the next slide. Thank you. I'm going to share my STEM journey now. I worked on my first microcontroller-based project on Arduino. It had a motion sensor for switching off lights. This project directly helped to reduce the power consumption within any household. During my college, I built my first robot. The picture that you see there, the scrawny one, that was my first bot. But since then, I've worked on multiple robotics projects through my junior year. In my final year, I was fortunate enough to be able to get a scholarship to do my bachelor's project as an exchange student in Barcelona. There, I developed a PCB board for CMOS MEMS accelerometer. Accelerometers are devices that are used in automobiles for navigation, vibration monitoring, and even in our cell phones. For my master's, I did 2 projects with NASA. The first one was designing some parts of the retarding potential analyzer on satellites flying on the low Earth orbits that provide diagnostics of the thermal ion distribution at the ionosphere. This RPA technique has been there for decades, but the caveat with the previous versions was the size was huge and the weight was high and the power requirements were not compatible with the low or resource specifications for nano satellites. So the project that I worked on was the first one to fly on a nano satellite mission. I designed the multiplexer, demultiplexer, UART, and counters for modules for this project. The second one was I helped to develop a wearable solution for alerting astronauts inside a space vehicles during their IVAs, that is the intravehicular activities for any emergencies. Or just imagine this, when astronauts are sleeping or exercising, they might not notice the alerts that are there on the different panels for them. So this wearable alert system was a solution to catch their attention under such conditions. The alerting mechanisms used or different modalities. It had visual alerting, auditory alerting, and haptic solutions, and that they came in different form factors of bands, straps, and garments, and things that they could wear on their t-shirts. They can be worn over normal clothing, so it was not anything fancy. And the proof of concept for this was a vest that I had designed for construction workers. I had gone to NASA in Houston to present this project, so it was a very cool experience for an engineer. My Intel journey, I started with Intel about 6 years ago now as an intern, and then I converted to a full-time. I started my full-time and I've worked in 3 different domains. They involved being an analog mixed signal verification engineer, where I owned the verification of PLLs, that is phase lock loops, which is responsible for clocking in the chip, and also thermal sensors for a 5G baseband chip. Currently, I'm working as a SoC design engineer for the 3D Crosspoint memory controller. Outside my day job at Intel, I've held various leadership positions with the next-gen ERG to champion early career employees for their career development and integration within the Intel culture. Thank you. I think, Alex, you're on mute.
Oh, there we go. Still in 2022, that mute button still gets you. Thank you so much, Namitha. And now we're going to pass it over to our third engineer. And again, we're going to kind of continue with the theme of, very different types of engineers and people with very different backgrounds. So Shayan Dev, who in the world are you?
Oh, okay. Can you hear me?
We can.
Oh, hi. Nice to meet you. So I actually have a small connection with MESA beforehand. Last year in 2021, I was a mentor for the MESA program with a cohort of students. So it's great to be back and great to see Bianca and communicate with her again. Nice to meet you. So my journey is a little bit different. As you heard, the last speaker had a wish of already very interested in electronics. When I was in my undergraduate, I had no idea what to do. I suffered from complete indecision, or extreme indecision, I would rather say. And I started my journey as a mechanical engineer. And in my junior year, till my junior year, I was acing courses. I did not like many. I was very good at getting good grades, but I probably didn't learn very deep into many of the concepts. So, and I was very confused about what to do next, about my career and about my thoughts. So in my junior year, I remember the first semester or the fall semester, there was a course on mechanics of materials. And the instructor, I really liked the way the instructor taught. So one day there were these midterm exams, and after the midterm exams, I was helping the instructor carry the sheet of the exam papers, and he asked me that you seem to have performed very well. What do you want to do? And I said, I have no idea. I like your course, but I have no idea. There are many of these other curriculum topics that I don't like. I'm not sure what I want to do. And then he told me that, well, the disease that you have about your own field, I also had the same disease. And I also did not like many of the topics that I was asked to learn. I liked the one that you liked. And I immediately started having long conversations with him. After that, his career track was, he did the undergraduate at the same institution that I did in India, and then he did his PhD in Cornell. He was a postdoc at Cambridge, and then he eventually went back and started teaching there. He is the person, Professor Ishan Sharma. You can still find him inspiring some other people. I hope so. He inspired me to actually come up for graduate school. I realized that graduate school only happens if you gain a significant potential in one topic. So his inspiration made me do a master's thesis with him in India itself. And then I started my PhD at University of Maryland. This picture on the left is literally the peak of my graduation. PhD graduation happens differently. PhD supervisor, here you can see this person from behind, Professor Siddhartha Das. He is actually hooding me. So usually the supervisor comes and puts this layer of clothing behind your back on your shoulders, or the tassel that you saw. So this is what happened at University of Maryland. I did do my PhD in material science itself. I changed completely from mechanical engineering. After that, I went to Harvard as a research fellow. So there I spent a couple of years before again, so I just liked what I wanted to do. I did not know what to do next. It has always been a constant issue with me. So this central character that you see in this picture in the left bottom is Professor Masao Doi. He is a very famous Japanese professor in polymer physics. When he did his seminal work in Cambridge, nobody knew him. He went back to Japan and he has serious issues in speaking English, because he is not a native speaker. He continued working in the field of polymer physics. His theories were rejected for 40 years. In 2003, his theory started getting proved, which he wrote in 1970s. He eventually won many, many awards, and he's a seminal contributor in the world of polymer physics. He remains one of the unsung heroes of polymer physics till today. I had the outstanding luck of meeting him, and he's a pioneer in what he has done. And he told me that don't worry about pioneering work. You will not get recognition, but eventually somebody will realize this madman has done something great. This was exactly what he said. Maybe his English was not very good. It did not come out exactly in this way. Imagine a Japanese person speaking very English in a very constricted fashion. But this is what was the essence of the conversation. I got so inspired by him that I decided that I would actually lead and doing things which are obscure and probably humanity or people will not see for a long time. And my Intel work, so after my Harvard journey, I was at a conference and there were many Intel researchers, and they actually asked me to give an interview at Intel about the work that I was doing at the time. So if you look at my Intel work, even none of these have actually shown up in real life. They will take time to show up in real life. So in Intel work, I started my journey with what we call an Intel 4 and an Intel 3 process. So these kind of semiconductor technologies will show up in the market maybe about 3 to 4 years from now. And the current one that I'm working in, which is PowerVia, we have just announced it in 2021 as a design and as a proposition of making the tiniest, that smallest aspect ratio structures ever made by mankind. These colorful glowing pins that you see, golden colored, which are glowing, these are called through silicon vias. These are the smallest through silicon vias ever manufactured by anybody in this entire planet. So, as usual, this will not see the light of the day as a product in some due time, but we will keep working. As a defect metrology engineer, I actually own the entire process and patterning of these through silicon vias. Now, my interest, for a long time in Central has been on imaging. I have always loved taking photographs of things at a very, very tiny scale. This brings to my first female inspiration, Rosalind Franklin. In 1940s, 1930s, she was a Jewish British woman in King's College, London, who is one of the first crystallographers of the entire planet. She actually invented three things for which we are all indebted. She actually invented the structure of coal. Not mentioned here, she actually invented the structure of coal. So fossil fuels, which we have used for many, many years, now we are trying to get away from it. Actually, she is the person who taught us how these polymeric chains look like. Then she invented the structure of tobacco mosaic virus. This was the first imaging of a virus ever done in this entire planet. We have all been thinking about coronaviruses and all the structures that people have been showing on the internet and CNN. The origination of how to make a structure of a virus comes from this lady. Then she invented the DNA structure. She is the person behind what we call photograph 51. You can read about this everywhere. If you Google photograph 51, everywhere you can read about this. She and her student took the first picture of this DNA helix spiral. She died of cancer the year before, actually a couple of years before the Nobel Prize was awarded. I have no idea why this lady was not awarded a Nobel Prize. Nobel should actually think about their awarding policies probably. But humanity is indebted to this lady for pretty much our life, right? Our science, the way life sciences is viewed, she is the person who actually did it. The next person, right to Rosalind Franklin, is actually a person who is alive. And I have the pleasure of actually saying that she is my mom's friend. So she is an aunt. So Dr. Reena Das is currently the director of integrative biology and behavioral sciences at National Institute of Minorities Health and Disparities. So she is a researcher on health disparities between communities around the world. When she started her STEM journey, she did her PhD in India, and then she started as a postdoc at NIH in 1987-88. There were like 6-7 women at the time in the entire institute, you can imagine. And she was one of them. And at that time, she worked on a drug called tamoxifen. Many of you might have heard or might not have. It is still one of the most prominent breast cancer drug in the entire planet. In 1990s, they started thinking about tamoxifen as a drug for breast cancer, and they started working on something called the concept of angiogenesis, which was occurring at that time, to understand cancers the way we still actually understand them. She is one of the pioneering researchers of that field. She's still around and still in Bethesda, Maryland, and trying to understand health disparities among many, many communities. She leads the, you can see, integrative biology and behavioral sciences division at this institute. So having a conversation with this person makes your feet tremble, because you are talking with a giant. As Newton says that you're walking on the shoulders of giants. This person is really one of them. I have two hobbies. One is a hike, which is in the lowest part of the picture. I usually like taking stony hikes in some regions. So this all these two pictures are from the Pacific Northwest. I deliberately included pictures from the Pacific Northwest. You can see I'm taking a hike in the fossil beds, which are these thousands of years old rocky fossil beds in Central Oregon. And this is actually a very unvisited place called Clarno Unit, which not a lot of people visit. This is a little bit obscure. So I'm trying to go towards the stone fortress that is there. It looks beautiful. And the other one is Hurricane Ridge. This is probably wildly popular. It's in Olympic National Park. But I have another odd hobby, and that hobby got to me in my grad school because of some work that I did, and then my Harvard life, where I was heavily invested into it. And I still collect samples and send them to my friend Netsida in Cornell. So I collect ecological samples of massive biodiversity. So in this planet, there are many, many areas where, there is extreme biodiversity. And these are kind of lost areas, these are forested lands. So if I visit there, I collect samples of biodiversity to look at many, many kinds of species that can be available in those areas. And then you can do an analysis at a lab. Usually, currently, I can't do it in Intel, but I send the samples to my friend and collaborator for a long time, Ned Jamsira in Cornell. But I used to work with Ned. So if you look at the left-hand photograph again at Harvard, the leftmost person is Ned Sira, who has been a long time friend. So his picture is there itself. So he and I used to do this, and I have collected samples from all sorts of odd places, from sulfur mines in Sicily to Denver, to some mines behind Boulder, Colorado. These two are in some of these places in Oregon. I have done. One is this Nescoin Lost Forest, which is an Oregon coast area. I do not know whether I visited this beach. This beach has odd trees coming out of the shore. And the other one is Devil's Sponge Bowl, which is inside another area where you can see these beautiful colors of fungi and beautiful colors of algae, red, brown, green, very vibrant across the walls. So I was trying to see what kind of interesting diversity is there. So yeah, that's kind of how I like that interesting project. Yeah. Thank you.
So wow, friends, this is awesome, and I almost apologize to our audience because I am not nearly as interesting as these three folks. And really, to go and put it into context, what you all just heard. I mean, you've got Becca over here, literally started, as a lifeguard at a swimming pool, which is a job I'm sure so many of you all can relate to, and now is literally in charge of, helping to purify all of Intel's water. I mean, we're talking millions and millions of gallons of water. Like, how many swimming pools could that potentially be? You got Namitha over here, way back in the 5th grade, where she was scared to even just talk to people. And now she's in charge of helping to coach others to be able to public speak and to present themselves and to share their ideas, both in her day job and as a leader at Intel. And then, of course, Shayan Dev, who his initial inspiration was all around this idea of being able to rub shoulders with these giants of the field, people whose work would literally go and define generations of technology. And now he gets to go into work on that next generation of technology that's going to go into our laptops of the future, our cars of the future, our, in some cases, maybe even our phones of the future. That is just absolutely amazing. And for myself, again, I'm not nearly as interesting, folks. But Alex Berry here, I work as a technical program manager at Intel, which that's just a really, really fancy way to say that I go and I help manage different technical resources and technical programs. So think of me as like a leader of a club, and I will go and I will sort of get assigned a new club every 6 months, 18 months. And then it's my job to help go and make sure that that club actually accomplishes the club's activities. I'm sort of in charge of making sure that we build in new backend databases. And I do a lot of work with Intel's internal data. And then also as a technical program manager, my job is to make sure that, we don't just say that we're going to go and do a really cool project, or we don't just say that we're going to use people's time to deliver a new solution, but we have to do it at the right time. We have to do it at the right cost. Intel has lots and lots of money, but if we say that it's going to take $1 billion to do a program, we can't spend $1 billion, right? That would make the cost for the products that you and I use every day way too expensive. So I'm very much there to help to go and kind of keep the team on track, manage some of the risks that our programs might have, as well as to make sure that we keep the cost reasonable. My background, I actually came from Southwest Georgia. I'm from a town called Albany, which is a majority African-American town where we really don't have a lot of different types of industries. We don't have a lot of really cool things like STEM. Or when I was growing up in high school, we didn't have robotics clubs. We didn't have clubs like MESA. And so I had to go and kind of really get into a lot of the different activities that we did have, which for us was sports. I played soccer and basketball growing up, and I still do today. I was able to do a lot of volunteering when I was younger. And partially for those reasons, I was actually able to travel when I was maybe just in middle school as well as in high school, and was able to travel around the world. That very, very much got me just really interested in other people's cultures as well as with food. If I'm honest, I probably mostly like to travel because I love to go and eat food from around the world. And that ended up leading me to go and see a bunch of different countries, a bunch of different cultures, and really understand the history of the people who lived in those countries. Academically speaking, I ended up going and kind of tripping over into a calculus class over in high school, and somehow I sort of never found my way out of engineering. So when it was time to go to college, this whole idea of, doing something interesting, doing something where I could sort of take my understanding of different things around history and culture and, be able to actually do something with it, maybe a little bit unlike Shayan Dev, I wanted to see a problem and solve it today. I wanted to see a problem and solve it in a month. I wasn't necessarily patient enough to wait 5 or 6 or 7 years for people to go and see some of the validation around my work. So I decided to go and pursue environmental engineering. It wasn't for me. And then I said, okay, I was good at biology in high school. I really liked some of the dissection stuff. I really liked some of the different areas around how the body works as a system. So I'll switch to biomedical engineering. I think I stayed in that for about 2 days until I tried something else. And after about 3 or 4 other major changes, I finally found this thing called industrial engineering. Now, for anyone who doesn't know, industrial engineering is like being a business major, a computer science major, a math major, and taking pieces of all of those things, mixing it into this kind of like giant academic milkshake, and then you get to call yourself an engineer. One of the things I loved about, and I still love about industrial engineering, is it lets you go in and take some of those pure concepts within the math and the statistics world and directly apply them to different types of business problems. So I don't really have necessarily a specialty over in a certain part of physics or a certain part of like electronics, but I learned how do you go and build different systems mathematically and through computers to go and represent the world that we see around us. And then how can you make money from it? How can you make money? How can you save money and apply those concepts both in the private sector, like what we do for Intel to help us make a lot of money selling our amazing chips and technology, but also save money for consumers? And then take that exact same methodology and those exact same skills and apply it over into working with different nonprofits and to helping them deliver their services to folks who really need that help. That really goes and kind of leads into what I do with a lot of my spare time, which is really around, both of course playing soccer and basketball, but also being able to go and spend a lot of time in the nonprofit space, helping different nonprofits think differently about how they go and they serve their target audiences. And then that also involves just a lot of mentoring with folks. Let's see, I think the only other 2 things that I'll go and I'll mention, and this is going to be kind of deceiving from the photos that I have, I am not a big hiker, but over in 2021, where a lot of those activities that I really do love and enjoy maybe weren't as accessible, I was just really, really lucky to get a group of my friends together, making sure that we could really get outdoors and explore all the wonders that Oregon has. So even though I'm not a big hiker, it is really, really nice just to kind of get away from a computer screen, which is where I spend most of my time. And then kind of as we shift into 2022, I am a lot more interested in things revolving different types of games, whether it's board games, sports related games, anything where you can go and just get a group of people together, have a fun set of rules and have just a little bit of competition, right? I love, love, love being able to go and get people kind of rallied around different concepts, especially when you have money involved. Now, just to kind of go just a little bit back into like my STEM journey. So most of the time when you're going into STEM, your STEM journey might look very, very similar to some of our other 3 panelists where, you find something that you really, really love and you say, oh my gosh, I'm going to dedicate the next 5 years, 10 years, 20 years to developing technology and solutions in this space. Again, for me, I was kind of trying to avoid certain things. So, when I was over in high school, I did like literature and I did like history, but I didn't really love to write all that much. And so I kind of actually sort of stayed away from many of the things that I didn't like. And that actually helped me go and sort of accidentally go and find many of the other different majors. Also, oftentimes, when you're in high school, sometimes you might be pushed to go to do certain clubs because it might look really good on college applications. For me, I sort of stayed away from any class that I didn't really resonate with the professor. So I didn't take physics in high school. I didn't take certain math classes in high school. And I just really went and stuck with the classes that I truly either enjoyed or maybe just had some really interesting people in those classes. So my background coming from high school was no coding experience, very little understanding of computer science, maybe slightly better at math than the average person, but not nearly what a lot of my friends in undergrad had from their academic backgrounds. So fast forward 4 or 5 years, and now we're over and we're in undergrad, where I did my undergrad at Georgia Tech, which is a really big engineering school in Atlanta. Something like 90% of the students are doing some type of science or engineering. And that was really formative because that was when I got my first chance to really do some really high level coding. And I realized, oh my gosh, I love this stuff. I got to do 4 internships for 4 different companies. That was also really amazing because I got to work for, huge, big chemical plants up in Michigan. I got to go and visit paper mills over in Savannah, Georgia. And I got to go, of course, go and come and work for Intel doing some really nerdy kind of back-end data stuff. That also just kind of reinforced in my mind this idea of being able to go and kind of travel around the world and help people with their programs and help people with their projects was something that I wanted to do more long term. And that really led me into the type of work I do today, which is in that realm of project management and really helping those really amazing technical specialists kind of move together to deliver things on time. And then finally, the last thing I'll say before I turn it back over to Bianca is my STEM inspiration, kind of similar to some of the other folks, is very much space related. So Katherine Johnson, for anyone who has remembered the movie Hidden Figures, is actually one of the kind of core mathematicians behind doing our first calculations for the US flights in terms of going and like sending a man over into the moon for NASA. One of the things that I really resonate with her and her particular story is that she had to do math and be that really amazing sort of feminista before it was cool. Especially back in the 50s and 60s and 70s, it wasn't always as accepted and as empowering to go and to be a Black woman, particularly a Black woman going and working for an organization as crazy and as amazing as NASA. So she had to deal with a lot of adversity purely because of her skin color and people allowing her to go and to bring her gifts to the table. Often, I know, like for myself, there's always been times, sometimes in my academic journey or in my professional journey, where I've really had to go and kind of dig deep and be really resilient to make sure that some of my solutions or some of my voice was gone and heard. And so I just always looked at her as an example of being able to go and to really push through and be really confident when I'm speaking in terms of my technology solutions. But yeah, with that, that's my background. Again, a little bit more of a generalist than some of our other panelists, but friends, we are just here and happy to go and answer any and all questions that you all could go and have for us. So I'm actually going to stop sharing my screen and turn it back over to you, Bianca. And with that, are we ready to go and start taking some questions, or did you have some for us, Bianca?
Bianca, you're on mute.
Thank you very much. Okay, so you all can see my proper screen and slideshow now. All right, yes. Thank you. So I just wanted just to go over how the Q&A works. There is a Q&A button on the bottom of your screen. If you click on that button, you should be able to submit a question. You'll be able to see other people's questions and you can upvote them. I will read out the question that comes to the top. So the most voted question I will read out to our speakers, and then the speakers will take their time to answer. Speakers, you don't have to answer every single question, but you are free to if you choose to. And then we'll do our best to get to as many questions as we can with the time that we have left. So please, for our audience members, please go ahead and submit any questions to the Q&A. And I will start with my question first. Well, first of all, thank you all for speaking and sharing your journeys. You know, you all come from different backgrounds, but you have arrived all at Intel, which is an Intel in Oregon, which is a very special and unique place. What has been, I would say, the most interesting part of your journey to Oregon through academia and through work? Or maybe the most challenging? Let's start there.
Becky, you want to kick us off?
Yep.
Sure. Yeah. The question was, what was the most challenging part of like coming up here and working at Intel?
Yeah.
Yeah. I guess I would probably say adapting to how fast-paced it can be. And you know, some people might view that as something that's negative, but I really see it as like it's a really great challenge. And being able to manage that you know, fast-paced work environment that's, you know, super rewarding, but also manage, you know, my stress levels, my work-life balance. That was probably the most challenging part for me. But that also came with like the transition from, you know, right when I graduated college is right when COVID started, and I had moved across the country. So there was a lot of like big changes going on in my life, and I had this new job that was very, you know, fast-paced. And so I think that was probably the most challenging part for me. But once that I was able to, you know, learn that balance, I find my job really rewarding because it is so fast paced. You know, it's always something new. You know, something different is happening every day. There's always a new problem. And that's, you know, part of the reason I love my job so much.
Nimitha, what about you?
For me, one of the biggest challenges when joining a huge company like Intel was just understanding the different things that are going on. For example, in my first meeting, they used to throw out so many acronyms that I hardly understood like 20% of what they were even talking. Other than the English words, I didn't understand anything. So just going in and figuring out what they are talking about, it took some time. So one thing I did was I reached out to different people across Intel, not just within my org, to understand the bigger picture of how a chip gets manufactured from the design side to verification and how it goes into the fab. So people were very generous with their time to mentor me and help me get started to understand the bigger mechanism within which Intel operates.
I can definitely see where you're coming from there, Nimitha. I know for myself, it was always really difficult because there's not that many people in my family who have a background in STEM and engineering. So I couldn't, you know, just like call up my family necessarily and be like, how do I navigate this organization? Or like, oh my gosh, there's 20,000 people and they're all sending me emails. What do I do? So it was maybe a little bit difficult for me to adjust to just working in a bigger, larger organization. But very similar to Nimitha, being able to go and kind of take it one step at a time, and also just being able to find mentors.
Did
who
Alex
could help
get?
technical programs or technical solutions wouldn't get the. What was it, Shayan Dev?
I think Alex, you got cut off for like maybe 5 seconds in the middle. So we, yeah, internet blurb as it happens.
Thank you for that. But no, I was just saying that it's just been really helpful to go and to find a lot of those really key mentors who can help me go and sort of navigate what it, at least for Intel Oregon is a 21,000 person organization. So even going and doing events like this where you get to meet people who are coming from our corporate services space and handling our water and our utilities, or people who are designing our chips, or people who are actually making the chips, makes my job a lot easier. Kind of understanding how do we make all of this in a cost-effective solution. So, but it was definitely difficult not having a lot of family members who really understand the job that I do, who could give me some guidance on that.
Yeah, so I think I can speak. The thing is that my first change was a change of weather. I came from Cambridge, Massachusetts, where it snows a lot, to a place where it rains a lot. So unfortunately, I have been at places where things always fall from the sky. They can be either solid or liquid. That was a change. Number two was the fab itself. So I am one of those employees who actually has to go inside the fab or factory that Intel keeps on building around the planet and tries to bring semiconductor supply chain balance. You might have heard a lot of news about it. So I am one of those people who goes into that factory wearing a bunny suit, which actually is a thing that you have to get acclimatized with for some time because of the temperature issues. The fab is always maintained at a certain temperature, and you are wearing practically a space suit where I have worked in clean rooms before, so covering up nose, face, and things are different, but the bunny suit is not something that no other clean room in academia people use. It's very special to Intel. So you have to wear a space suit and go inside. So that takes a little bit of, setting up a mind in the morning to, make up a point. And in the beginning of the pandemic, it was a very difficult time in the factory because a lot of people were very afraid. There was a time in the month of, let's say, April 2020, where people had no idea about masks. People had no idea much about, we just knew about social distancing. So, and at the time, Intel was going through a very big transition because we were providing a lot of products for medical industry. And ventilators that are made by Medtronic use something called FPGA. These are electrical circuits that are made by Intel. Whatever was their demand shot up by 20 times in one night, as you can expect. And we had to somehow manage to make those. Given that I work in research, our production teams were so thinned out because of this increased demand of products that we never expected, that we had to move from research into production. And pretty much take shifting jobs that the production people do. Say night shift, day shift, doesn't matter. So it was very interesting for people like us to stand in a long queue of getting our temperature checked in early mornings, socially distant, in the Oregon rains and cold, wearing a bunny suit, standing outside to basically try to make these products for Medtronic. It gave me a purpose in my life. I can definitely say that.
Okay. Thank you for those answers, everyone. So I have one question, and it's actually in the chat. Besides filling out applications, how can someone stand out for internship opportunities at Intel?
Yeah, maybe I'll start on this one, and I would love to go and hear thoughts from the other panelists. So especially at a company like Intel, where everyone is super smart, super engaged, it really does make a difference when people are able to go and to be able to show and to demonstrate their passion that they have for a particular area of technology. And it's even better when you can go and you're able to sort of tie that passion back to something that you're just interested in, maybe just in your regular life. So for myself, I was really passionate about going and managing other different types of teams, other engineers, to go and to be able to do really cool projects, right? Sometimes that's creating a cooking show and tricking hundreds and hundreds of people to come on Zoom and cook together. And sometimes it's using those exact same skills to manage multi-million-dollar budgets while I was over in college. So it really is about going and figuring out what are some of the skill sets you have, and then being able to link those skill sets to some really specific projects that you're able to go and to talk about and to chat with. And then the last thing that I'll say that I found really helpful was, especially when I was in high school and undergrad, I knew what some of my skills were, but I didn't necessarily understand what those skills would translate to over in the working world. So like I did a lot of teaching and training and being a TA and things like that when I was in high school and in undergrad, but I didn't know what job that led to. So for me, the mentors that I was able to go and get during my undergraduate career, and even like upperclassmen who had sort of worked a lot of these jobs for these companies that I was interested in, they were able to teach me, hey, Alex, this training job that you're doing in undergrad, you're going to build these skills that's going to help you in a project management organization. Or this statistics class that you don't really like that much, this is actually going to really help you for this industrial engineering role at Intel, and this is what matters. So again, the tying your skills to your projects, as well as getting mentors who can help give you a perspective of, wow, you're doing cool stuff, but this is what really truly matters about that, can really help to accelerate some of your learning, as well as help you figure out how to make that pitch to a bigger technology company like Intel. But we'd love to hear some thoughts from other folks.
For me, when I started as an intern with Intel, that opportunity came because I was working with my professor, and that professor was my doorway to the Intel world. Professors usually have projects they've done in collaboration with companies before, or they have students who have graduated from under them and have joined companies who send out job recs or internship opportunities to the professor. So being in touch with your professors is one great way to, stand out in addition to applying online for the different jobs.
I can speak.
Go ahead,
So
sorry.
there. So I just saw silence to cover. The thing is that I think other than application, one thing that very importantly matters is, I think it's called networking. Uber important. So you want to work on a topic, you would try to find out people who have worked on that topic before and try to make a one-on-one connection with them. These days, there are many online tools, and I think you guys are more familiar with them than me sometimes, that you can use, because there are so many online tools coming up that I have been catching up to actually keep track of them. So there are many other online networking tools that have come up, and everybody can, these days you can fix up a Zoom meeting just like that, or some other communication meeting, Skype, Teams. There are so many versions of this video conferencing systems that you can have an information session or informative session with somebody for even a 10-minute. And that would give an introduction to what they do. That would give an introduction to what the company does. And that would also give you a chance to understand whether you are even fit for that or not. These are three things that are very important to know. And that would make your application, like any application that you make, you want to, how do I say, cartel it, or you want to make it such that it is kind of designed to address the questions that this internship wants, this internship application wants in an intern. So that would help you to actually shape your resume and your whatever statement of purpose, or whatever you might want to call it, like cover letter that you write for any of these things. And also it might help you to actually have a one-on-one connection with a person who is hiring an intern. Right, or that person can connect you with somebody in the team who is hiring an intern. So in that way you can have a straightforward things. And it also happens in the job world. During the pandemic, many students from my earlier universities contacted me. I was not a part of the hiring team, but I knew a lot of people who were hiring a lot of people. I definitely made sure that the resumes were directed to those to those hands. So that networking part definitely helps.
Yeah, and the only thing that I would add is it can be really hard sometimes, but try to be resilient in your applications, because you might hear no a few times before you hear yes. I was able to get an internship with Intel through a connection that I made at a previous job, but that previous job that I had, I think that I had sent out 30 to 50 applications before I got a couple interviews. And so sometimes you really just have to keep trying before you get that yes. So networking and soft skills are so incredibly important, and I would probably say more important than resilience. But what's really going to make you successful is if you don't give up and just keep sending in those applications, keep trying. If there's other job that might pique your interest, apply to that. Maybe apply to a job that is just kind of related to the job that you want, and kind of get a foot in the door there. But just starting off that way is really going to help you get your career goals that you want.
Thank you all for those answers. And I just wanted to kind of going along with what Shayan Dev and Becca were saying about like networking and using online tools. There are a lot of people who are doing fascinating research who share their research via social media. So that's one way to get connected with like what people are doing at Intel and at different universities. And so if you're unsure or trying to stay informed, that's a pretty easy way to start and possibly make a connection. So, you know, I know all of you are on like TikToks and things like that, so you can follow you can follow some engineers and scientists as well. Okay, do we have more questions? We have some time left, and if any of the students want to submit more questions, please click on the Q&A button at the bottom of your screen. Can you all see the Q&A button? Can students, can you give me like a thumbs up in the chat if you can see the Q&A button? I just want to make sure. Okay, all right, so let's see. Let's say what is I don't know, what's your one piece of advice for students now who are trying to figure out their path, especially in the world that we're currently in? You know, we're living through a pandemic. There's many other things happening in the world that are affecting us here, not just here in here in Oregon, but in the States and around the world. So what's your advice for students kind of moving forward and how to be change makers?
Ooh, that's a wonderful question, Bianca. And if it's okay if the rest of the folks, I'll go ahead and start off on this one. So really, I interpret that question around like, you know, how do you deal with this like kind of crazy uncertainty that we have? You know, stuff's starting to open back up, but stuff's still kind of weird. You know, people are kind of to hug you, but you're more like an elbow person, but you're also trying to make some really cool change in the spot where you're at, right? I think for me, it goes and so comes down to some of the core principles that I got out of my undergrad, which is, you know, especially for those of you who maybe haven't necessarily found your one overall passion or that one really amazing strength that you really resonate with. Until you find that, to be perfectly honest, I still do just love going and finding people who maybe have found that passion. And I'd like to say to them, hey, Namitha, hey, Becca, hey, Shayan Dev, you're working on something really cool. Is there something I can do to help and support you? One of the things I love about doing that, and especially until, you know, maybe you go and you find your overall dream or your overall passion, is that it lets you go and increase the amount of time you spend with people who love what they do, who are really, really interested, and who oftentimes all they're looking for is someone to go and to be able to share their creativity and share their passion with. That's a great way to go and to be able to develop skills and also help other folks make a difference. So like I know in undergrad, I wasn't necessarily the most passionate person about sustainability and recycling initiatives, but all of my friends were really into that. So we were able to write environmental policy. We were able to make huge recycling initiatives. I was able to be part of programs and projects I never would have even dreamed about, just because I just really enjoyed hanging out with those people, and those people loved hanging out with sustainability stuff and recycling initiatives. So yeah, for me, especially when you're looking at like these particular times, you know, are there any folks who might be within your high school clubs or in your MESA clubs who maybe even outside of MESA are doing something that you're just really, really interested in, and you just maybe want to go and maybe help and support them? It can just be a really, really good way to figure out what you're good at and what you're maybe not so great at. So that way, when you do go and figure out, hey, what kind of team do you want to build? You already have a lot of folks who are ready to support you in that journey.
Well, I feel my piece of advice would be, don't feel that you're locked into any specific college or your career right now. Just try to understand what your interests are. Just talking to as many people as possible and being genuinely curious in different fields. No one had expected the pandemic to happen 2 years back, and all our plans were just thrown out of the window. So being in that growth mindset where you just want to learn and be open as a sponge to absorb everything, that'll really help you in finding your place.
Yeah, I just wanted to say that it's okay to feel like if you don't know what you want to do or you're really unsure right now, that's very, very normal. you know, I had this, I've worked in water since high school and I really enjoy it. But when I was in high school, if you asked me what I wanted to do, I would really have no idea. I just kind of started to get more involved with things that I enjoyed, and that led me to where I am now. So, you know, with everything going on, it can be kind of difficult to say like, this is the path that I want to take, and this is the thing that I want to do. And that can be like a lot of pressure. But if you kind of lean into your interests, or, you know, what makes you happy and what you're interested in, you'll be really surprised with the path that leads you down, and the little nooks and crannies that you can get into that way. So.
So following Becca, actually, I would say, Rebecca, I think it's a very, like, it has happened with me many times and it still happens. I suffer from indecision. And if you suffer from indecision, I would say that is actually a strength. It is not a weakness. Indecision leads you to explore multiple venues to make a decision. And that's how you get to understand many things, and maybe you will find something that you will like, or you will meet somebody who will say that I have the same disease as you, as my story started. Each of these methodologies are possible. You either get inspired by somebody or you figure out on your own. So being undecided is fine. I'm still undecided what I'm going to do next. So it's a very important, I think, so many people from the very early beginning, as I have met many people who are very decided and they have an idea of what to do next and what they want to do, and etc. and etc. My problem has been I could never answer what I'm going to do. And as a result of that, many people thought that it is a weakness that I have. But your greatest weakness can be your greatest strength. It's a very big learning, and I would really suggest that you use that. So if you're undecided, you have no idea what to do, go ahead and start doing many things. You will probably find out what you want to do.
For those of you who are maybe like just a little bit risk averse like I am, you know, being able to go to have those wonderful little like mini experiments can be really helpful. So, you know, like Shayan Dev had mentioned earlier, you know, going and chatting with a professional in a field that you think you might be interested in for even 20 or 30 minutes, you know, that could save you, you know, tens of thousands of dollars later on in your career, you know. And sometimes you might go and have a chat with a professional, or you might take a class, or you might do a volunteer activity, and all you realize from that is how much you don't want to do that particular career field, or how much you don't want to do that particular academic journey. And that's fine. Sometimes it really is figuring out what are all the things I don't want to do, and then you'll have a nice little pool of things that's left, and you're like, I'll do industrial engineering. Sounds cool. Who doesn't want to make and save money?
Thank you all for those answers. We have another question in the chat. Would an engineering technician role be a good start for a recent undergrad with an engineering degree at Intel?
I can take that because I deal with a lot of engineering technicians every day in, day out. Yes, it is. So that job has actually a very hands-on approach to work, because you would be literally touching the things that Intel makes. What does Intel make? It's a wafer, right? We are a manufacturing company with a design and with our entirely own designs. So it also is a very interesting job because you will interact with the products, you will interact with the tools, and you will interact with how these things are made. Right, we always show these videos that we make the tiniest with these giant machines, which are of the size of a plane or a boat or something like that. You will actually get to not only work with that boat-shaped machine, maybe enter that boat-shaped machine because it is so huge that people can walk through inside it. Right. So it's a pretty cool job. The only caveat is that usually it comes up with a shifting arrangement that you work in, but that also is interesting because it's a compressed work week. So you won't be working 7 days a week, you would, or 5 days a week, or how they say it, like a full week. You will be working in compressed week. So you will work like 4 days this week and 3 days the next week. So as a result of that, many people enjoy specifically with the pandemic, many people have absolutely enjoyed the work-life balance situation that the job has provided. You work for 3 days and then you get to chill off for 4 days. Sounds amazing. And then, you know, you are stuck inside a factory for 3 days and then you get to maybe enjoy the Pacific Northwest roaming around. So so that's the thing. You get introduced to many tools and techniques inside the factory. You get to get introduced to the data that is actually used to run the factories, which is a very powerful tool at Intel. We haven't talked about it. Data is the godfather of Intel in some ways. So we use data so much. Everything is some plot somewhere that we actually produce. You actually will be able to produce that data. So that actually makes you a fundamental pillar of the entire manufacturing process. And you can see as American manufacturing is lagging, and from president to Senate to Congress to everywhere, they are focusing heavily on semiconductor manufacturing, inviting our CEO to the state of the, we are the state of the union. Intel is the state of the union of this of this country. You can imagine that an engineering technician is the first point of contact in that entire chain line. It's a very important and interesting position. So yeah, if you want, go ahead.
Yeah, I'll answer this one too. I also work with a lot of engineering technicians, and I think it's a great like starting role for someone with an undergraduate degree. I know a couple of technicians that have the same degree that I have. A couple of them have like moved to my position as like a system owner or facilities engineer. And it is one of those jobs where you get all of this hands-on experience, and you really learn the tools that you're working with, the systems, the equipment that you're working with. And that's something that, like me as a system owner, I wish I had more of that. When I have a problem and I really am like stuck and I don't know, which direction to go, I'll go ask the senior technicians because they've probably seen something like this before and they know what to do. And so having a technician role to start out with is an awesome way to start your career because you'll get some of this hands-on knowledge that is just so incredibly valuable. So yes, I would agree. It is a great start.
Thank you. Do we have any more questions from our students? Okay, if not, I think I'll make a few announcements and then we will thank our speakers. So let's see. So this is our schedule for Career Week. If you all are interested in coming back tomorrow, we'll be joined by First Tech Federal Credit Union. They'll be talking about their STEM jobs because they do have a number of STEM professionals, mathematicians and engineers as well. And then we're joined by Daimler North America, which is on Thursday. They'll be talking about manufacturing, right? And for our high school students, we have Invention Bootcamp. It is a free 4-week engineering and invention camp held at PSU. It is taught by Professor Jerry Rechtenwald, who is in the mechanical engineering department. That's July 5th through 29th. The application deadline has been extended to March 20th at 11:59 p.m. Those are the links to the applications. So this is for high school students. So if you are currently in 9th, 10th, 11th, or 12th grade. For our PSU students, if you're interested in being a mentor for the camp, please let me know. I will make sure you're connected with the camp organizers, and you could potentially have that as a summer job. Let's see. We're hosting family nights for MESA students, so please join with your families. They get to learn what MESA students do in their chapters. These are the dates. You'll get some emails coming up about that, and your advisors will let you know as well. And I just want to say thank you to you all for coming. Thank you again to our speakers, Alex, Namita, Becca, and Shayan Dev, who's left us. If you have questions, please go to everyday.oregonmesa.org. That's where we share all of our information for students, including upcoming events, how to follow us on social media, etc. And if you have questions, email us at ormesa@pdx.edu.